Okay, this is for solving quadratic equations by graphing. Yesterday, I just had you basically graph the quadratic equations. Now we're going to actually go through and solve them. The first thing the author talks about in this section is a quadratic. And remember, it's quadratic because the highest term is an x squared term. A quadratic equation in what they call standard form. You'll hear me say that. When you get it in standard form, okay, that means it's equal to 0. So you're going to have ax squared plus bx plus c equal to 0. So what they want to know is, where does that graph equal 0? Where it equals 0 is where it crosses the x-axis. Okay, so where the parabola crosses the x-axis, those are called, it depends on your author, they're called roots or zeros or solutions to the equation. So when they ask about solving the quadratic equation, they really want to know, where does it cross the x-axis? Okay? So there are three possibilities. Okay? One is you will have a parabola, and I'm just going to do one sketch of it. You will have a parabola that just touches the x-axis. Okay? And it's a quadratic equation. If it's an x, if you look at this in this form, this is telling you how many solutions you should have. Okay? You should have two answers. Okay? But on this part where it just crosses, or actually doesn't cross, it just touches, it's what they call a double root. Like you might end up with an answer like x equals 3 and x equals 3. It just touches. So this one, where it just touches, is called 1, and it is real, 1 real double root, or 0. Okay, so it could just touch, and it doesn't matter if it opens up or down. I mean, I could have one like this where it just touched at one point, but opening down. Okay, that's still a double root. Okay. Another one I could have where it crossed the x-axis. The roots or the solutions are where it crosses the x-axis. So this one would have two real roots. And in this case, I'd have one that's negative because it's on the left side of the y-axis, and one that's positive. Okay, and then the other possibility, the third possibility, is you might have one that does not cross. Okay, if it does not cross the x-axis, yeah, then you say no real solution. There is a solution, but there's no real, it's not a real number. Okay, okay, now I'm going to take you through some examples and actually solve some of these. So the first one, then they will just say in the directions, will say solve by graphing. Okay, and on this one, they're going to give you the equation x squared minus 3x minus 3x equals 4. You don't want to solve it in that form. You want to get the 4 over to the other side. So subtract 4. So you'd have x squared minus 3x minus 4 equals 0. Okay, and then to solve it, you actually need to set that equal to y. So you'd have x squared minus 3x minus 4 equals y. And now you do what we did yesterday. You know the y-intercept is the c value. So it crosses at negative 4. So go down 4 and put a point, okay, at 0, negative 4. to be able to graph it, you want the axis of symmetry. X equals the opposite of b over 2a. And remember, this is in the form ax squared plus bx plus c equals y. So my b is a negative 3, so it's the opposite of a negative 3 over 2 times 1. So I get 3 halves. Do you agree with that? Okay, so if I'm making a table, my x is 3 halves. That's my coordinate, and I want to do the axis of symmetry. So x equals 1.5. So at 1.5, we're going to do the axis of symmetry. Okay, and that means right now, if I've got a point here, if that's 1.5 units away, then I can go 1.5 on the other side. There's another one right here. Okay, and I can also look at that and say this a value is positive, so it opens up. So I know my vertex. I really need to find that vertex point. So sub that in. So to your x squared minus 3x minus 4. Sub in the 3 halves. Right, so that'd be what, 9/4 minus 9 halves minus 4 over 1. Check my arithmetic. I get 9/4 minus, common denominator before 18/4 minus 16/4. Agree with that? And that would be negative 9, negative, what do you get? Negative 9 and negative, you get negative 25/4. Yep, so that's a negative 6 1/4. Okay, so now I know my vertex point. So I need to go down 1, 2, 3, 5, 6 1/4. So I'm down a little bit, about right in there. Okay, and now plot. Let's try 1, 2, 3, 4. Let's try 4 for our x. So sub in 4. We're basically doing it kind of like we did yesterday. Sub in 4 in for our x. I'm going to do it over here. X squared minus 3x minus 4. I should say equal y on this. Equals y. So sub in 4. So I'd have 16 minus 12 minus 4. 16 minus 12 would be 4. 4 minus 4. Okay, that's one of our roots then. So y equals 0. So 4, 0. So go from the origin, go to the right 4 and up 0. So that's one of our roots. If that's, what, 2.5 units away from the axis, then there's another one. Does that look right there? Okay, so our 2 roots, when they ask what are the 2 roots of this, it would be, what's that one? That would be negative 1 and then up 0, right? So these would be the 2 roots. If they say, on this one, they said solve by graphing. Okay, so our 2, we would have 2 real roots, and the 2 roots are where it crosses the x-axis. So this one is 4, 0, and this one is negative 1, 0. Okay? And that's where it crosses the x-axis, and the y value is 0. You're looking for the y value to be 0. Okay, and if they asked you, they didn't really say on this one, but it's 2 real roots. Sometimes they call those roots, sometimes they call them zeros. Sometimes on the calculators they call them zeros. Okay, any questions on that one before we go on? Okay, another one. Let's try another one. Let's say on number 2, still we're solving by graphing. So x squared minus 4x plus 4 equals 0. Okay, and if we were going to graph it, we would change that to a y. First, it's going to cross the y-intercept will be 4, so plot that point. The x equals the opposite of b over 2a. You always want to find that axis of symmetry. So it's the opposite of a negative 4 over 2 times 1. Remember, it's in the form ax squared plus bx plus c equals 0. So we end up with just 2x equals 2. So plot that axis of symmetry. So if this is 2 units away, there's another one 0.2 units away. Okay, and then sub 2 back into the original to get your vertex. Your vertex has to have that as an x value. So if we're making a table, that is the x value. So sub that back in. So 2 squared minus 4 times 2 plus 4. 4 minus 8 plus 4. 0, right? So, okay. That means this is a double root. Okay. It only, because that has to be the vertex. Okay. So, this is a real double root. So, in other words, when you say, look at this exponent and there's 2 solutions, your 2 solutions are x equals 2 and x equals 2. It's a real double root. So this one is a real double root. And if they said, what's the x value? You'd say x equals 2. If they said the ordered pair, would be 2, 0. Okay? Okay, so, it's 1, I should say 1 real double root. Oops, sorry. I should say 1 real double root. Okay? So now we've had two different examples. Now let's do the third one. They're going to change the directions on this one a little bit. And I think I'll put it up here. On the directions on this one, say, find 2 real numbers with a sum of 4 and a product of 5, or show that no such, find 2 real numbers with a sum of 4 and a product of 5, or show that no such numbers exist. And then graph the function. Okay, when you're doing a word problem like this, you should always label your variables. So I'm going to just say one of the numbers, x is a number. If I said 2 numbers add up to 4, and one of them was 1, what's the other one? How'd you get that? Instead of doing addition, do it the other way. Do the total minus, okay? Like if x was 1, the other one would be 4 minus 1 would be 3. Put that in parentheses because that represents one number. And just say this is the other number. If it's a sum, you always put the total minus x. Okay, and now do the product. Product means multiply. So do x times 4 minus x. And it says that the product is 5. So set it equal to 5. Let me stop there. Everybody understand? You multiply them. And now when you multiply this out, you get 4x. You multiply this out, you get a negative x squared. Did it go off? No, we're still going. I hope I didn't. Okay, so now you've got the quadratic. Get it in the right form. Get it in what they call standard form equal to 0. And most of you are used to the positive x squared. So like I would bring this x squared over to this side. I would bring the 4x over to this side. And then get it standard. My 0 is going to be on the left side. And go descending order, so you'd have x squared minus 4x plus 5. And now it's in the form where you can graph it if you change this to y equals x squared minus 4x plus 5. So it's going to cross the y-axis at 5. So go up 5 and put a point. And we want to figure our axis of symmetry. X equals the opposite of b over 2a. So it's the opposite of a negative 4 over 2 times 1 is 2. So x equals 2 is our axis of symmetry. And our vertex has to be on that axis. So now sub 2 back into the original. Okay, can you do it by sight? 2 squared would be 4 minus 4 times 2 would be 8 plus 5. So negative 4 plus 5 would be 1. So our y value would equal 1. So if x is 2, y is 1. Okay, that's our vertex point. And if this one's 2 units away, there's another one 2 units away here. Okay? And then you could plot a couple more points, but you don't need to. You already know it's not crossing. Okay, so knowing that it does not cross the x-axis means there's no real solution. So no real solution. And that's what they ask, show that it does not, if you go back, show that no such numbers exist. Okay? Okay? It does not cross the x-axis. Okay? Any questions on those? So basically you're graphing them, and depending on what they ask for, usually they ask you for the solution. They want to know where is it crossing the x-axis. Those are your roots or your solutions.